Hello friend, today I am going to explain you all non-orthogonal multiple access, that is NOMA. NOMA is one of the key principles for radio access in 5G network. What is radio access network? A radio access network is a major component of a wireless telecommunication system that connects individual devices to the other parts of the network through a radio link. NOMA is based on the fundamental idea that more than one user can be served in each orthogonal resource block, that is time slot, subcarrier, spreading code, etc. NOMA is a technique in which multiple users share allocated resources through the power domain. It increases the number of simultaneously served users and thus it can support massive connectivity. In first generation of mobile communication, we were using for frequency division multiple access, that is FDMA. In second generation, we were using time division multiple access, that is TDMA. In third generation mobile communication, we were using code division multiple access, that is CDMA. In fourth generation, we were using orthogonal frequency division multiple access, that is OFDM. And in the fifth generation, the most promising candidature for fifth generation is NOMA, that is non-orthogonal multiple access. So we have to first of all make some comparison between the what is OMA and the NOMA. First of all, I will look at what is OMA. In case of OMA, you can see here easily that from the base station to the user 1 and users 2 in the first diagram having a channel coefficient H1 and from base station to user 2 having a channel coefficient H2. Here the frequency is being divided. For user 1 we have given the lower frequency range and for user 2 we were giving higher frequency range, but the power is same. But in case of NOMA, you can easily see here having the same channel coefficient H1 and H2 for user 1 and user 2 respectively. But in the power domain, you can easily see here the graph y-axis that power level are different for user 1, user 2, but the frequency band for both the user is same. We are allocating more power to user 1 and less power to user 2 in case of NOMA. We are just dividing each and every user in NOMA with different power level. Understand? So we have to make a comparison of NOMA and OMA. What are the advantages of OMA and what are the advantages of NOMA? First of all, I will discuss. Advantage of OMA is simple receiver detection, simpler receiver detection, and advantage of NOMA is having low latency, higher spectral efficiency, higher connection density, enhanced user fairness, support diverse quality of service. And then we talk about the disadvantages of OMA: lower spectral efficiency, limited number of users, unfairness for user, and disadvantage of NOMA is increases complexity of receiver. These are the disadvantages of NOMA. So we have seen here the NOMA system is performing better because it has a low latency. It means for delay in the transmission of data from one point to another point is low. It is a faster service. It is having the fast data rate and higher spectral efficiency, higher connection density, increased user fairness, support diverse quality of service. These are the advantages. For the better understanding of NOMA, I am going to find outage probability. Understand? So I have taken two users for that, user 1 and user 2. Our objective is to find the outage probability for user 1 and user 2 of a NOMA based communication. Here we have taken the system model. I explained you earlier what from the base station to the user 1 having a channel coefficient H1 and from base station to user 2 having channel coefficient H2. And in the power domain we can see here easily that in the power domain I have given U1 user more power and U2 user having less power, but here the frequency range for both the user is same. So at user 1 I am going to decode. How I am going to decode the data? You can easily here say that for U1 user I am decoding U1 user signal while treating the U2 user signal as a noise. Any data that is coming to user 1 will be composed of user 1 and user 2 data, but here it is going to detect the only user 1 data. How it is possible? Because it is treating user 2 data plus noise as a noise, so it will be removed. And here we have decoded the U1 signals of U1 user, and at user 2 you can easily here see that first of all I have decoded the signals of user 1 while treating the user 2 data as a noise, and then using the successive interference cancellation. Here the concept that we are using is successive interference cancellation. You can easily see that I have taken x1 data for user 1 and it will be detected first, and from the whole data I am going to remove the x1 data by using successive interference cancellation. You can understand easily by this term y is equal to x1 plus x2 plus noise. For decoding x2 signal I have first of all decoded x1 signal, and after having the subtraction from the y we have removed we have removed x1 signal, so we have got only x2 plus noise at the u2 user. And then at lastly you can easily have the decoding of u2 signal, and then we just recover the x2 signal from the whole data. Understand? I will explain in detail. So what will happen? NOMA downlink. I have suppose the system is NOMA downlink. A base station creates a superimposed signal containing data of both the user 1 and user 2. Here xs is the superimposed signal. It is equal to root under a1 raw s into x1 plus root under a2 raw s into x2. A1 and A2 are the fractions of total power given to user 1 and user 2. For power constraint, A1 plus A2 must be equal to 1. So, raw S is how much? Raw S is equal to PS upon sigma square. What is PS? PS here we have taken the total transmit power. Understand? And sigma square is the variance. Then what will happen at the receiver? At user I am supposing the ith user is going to decode the data. What will be the received signal at ith user? Ith user having a data equal to yi is equal to hi into xs plus ni, and where ni is the additive white Gaussian noise having mean 0 and variance 1. So I will just add for highest user at I am supposing at first user. At user 1 the received signal is how much? Received signal will be how much? Y1 is equal to h1 root into root under a1 raw s into x1 plus a2 raw s into x2 plus n1. So I am going to calculate the signal to noise ratio for decoding x1 signal at user 1. I am just representing it by gamma function. The gamma of decoding x1 signal at user 1 is how much? You can here see that it is equal to a1 raw s into mod of h1 square upon a2 raw s mod of h1 square plus 1. Here from the above equation, this equation you can easily see that what will be the desired signal at user 1. User 1 the desired signal is the first component. It has the three component, x1 component, x2 component, and then noise n1, that is noise. So the first term will be treated as this term a component of x1 is treated as signal and other terms, this term and this term will be treated as noise. So I have written signal to noise as first, this is the first component is that, and second and third component is that. So I have written the signal to noise ratio as A1 rho s in mod of h1 square upon A2 rho s mod of h1 square plus 1. I have put it mod of h1 square as beta 1, so I can write it ever A1 rho s into beta 1 upon A2 rho s into beta 1 plus 1. Here we can draw the PDF of beta 1, and PDF of beta 1 I have written here that f of beta 1 is equal to 1 upon delta 1 square into e to the power minus beta 1 upon delta 1 square, and beta 1 greater equal to 0. So what is delta 1? Delta 1 is a scale parameter of distribution. So I can at user I can also derive for the user 2. User 2 will be how much? Y2 is equal to h2 into a1 rho s into x1 plus root under a2 rho s into x2 plus n2. And here signal to noise ratio for decoding x1 signal at user 2 will be how much? Here also the first term is the desired signal and then remaining term will be treated as noise. So I can write gamma of decoding x1 signal at U2 user will be how much? Will be how much? A1 rho s mod of h2 square upon A2 rho s mod of h2 square plus 1, and I am again putting mod of h2 square as beta 2. I can write it easily as A1 rho s into beta 2 upon A2 rho s beta 2 plus 1. After decoding U1 user and cancelling the interference, I have just removed the first part. From here you can just remove using the successive interference cancellation, you can remove this part. The remaining part will be how much? A2 rho H2 into A2 rho s into x2 plus noise. After using the successive cancellation concept, I have remaining with the term that is a root under A2 rho s x2 into h2 plus noise term. So for SNR for decoding x2 signal at U2 user will be how much? Gamma of decoding x2 user, gamma of decoding x2 signal for U2 user will be how much? A2 rho s mod of h2 square is equal to A2 rho s into beta 2, and beta 2 is how much? Mod of h2 square. Then the drawing the PDF of that function will be how much? F of beta 2 is equal to 1 upon delta 2 square e to the power minus beta 2 upon delta 2 square. Beta 2 must be greater equal to 0. Then I have to find the outage probability. What is outage? Outage is referred to the scenario when the rate of the user is lower than the desired rate. Let's suppose U1 user is having the threshold, the desired rate must be equal to R1 cap, and R2 cap will be the desired rate for user 2. So I am going to calculate the probability of outage for user 1. The rate of user 1 is given as, from Shannon equation you can write that C of U1 user for decoding x1 signal will be how much? This is log on base 2 of 1 plus gamma function of x1 signal of U1 user must be equal to, must less than R1 cap. So I can write here gamma of x1 signal at U1 user will be A1 rho s beta 1 upon A2 rho s beta 1 plus 1. It must be less than 2 to the power R1 cap minus R1 is equal to R1. So beta 1 must be less than R1 upon A1 minus A2 R1 into rho s. So what will be the outage? Outage will be, outage probability for user 1 must be equal to beta 2 beta 1 less than R1 upon A1 minus A2 R1 into rho s. We are just going to find the probability, outage probability, we are just going to integrate it from 0 to that value, beta 1 value. So I am, after that expression, I have come with the solution that outage probability how much for U1 user 1 is 1 minus e to the power minus R1 upon delta 1 square into A1 minus A2 R1 into rho s. So for user 2 decoding fails, for user 2 what will be the outage? Outage will be when there will be decoding of x1 signal fails at user 1 and then decoding of x2 signal is also fails. So I can write the outage probability that it must be the union of the rate must less than C less than R1 and C less than R2 cap. This will be the outage where we have to find the union of both these things. So C of decoding U x1 signal at user 2 will be how much? Log on base 2 of 1 plus gamma function of decoding x1 signal at user 2 must less than R1 cap. And after doing the simplification of the above equation, we are going to get beta 2 less than R1 upon A1 minus A2 R1 into rho s. And again for decoding, for the rate, desired rate must less than R2 cap, we have this equation log on base 2 of 1 plus gamma 2 gamma of user 2 at decoding x1 signal less than R2 cap. And after doing the simplification of the above equation, we are going to get beta 2 less than R2 upon A2 rho s. So my outage, on solving the outage occurs only if beta 2 less than maximum of R1 upon A1 minus A2 R1 rho s comma R2 upon A2 rho s. So we are going to find the outage probability how? We are just going to integrate it from 0 to the maximum value of these two components. And after doing the simplification of the above equation, we are getting the term 1 minus e to the power minus of 1 upon delta s 2 square maximum of R1 upon A1 minus A2 and doing that we have gone with calculating. After doing that simplification, we have the MATLAB simulation result, and we can easily here see that the MATLAB simulation result having, we have the two factors A1 and A2, and we are given for the two user 1 and user 2. So for user 1 we have given the more power, fractions of power, that is A1 is equal to 0.9 and A2 is equal to 0.1. So we can easily here see that user 1 is being denoted by the red color line, it is having the less outage probability, and in comparison to user 2 which is having given the less power fraction, power fractions having the more outage probability is denoted by the black color line. So if I am going to increase the power fraction to the user 1 and decrease the power fractions of user 2, what will happen? This is denoted in this graph. This, after MATLAB simulation, we have find the result that if we are going to give the more power to those user, then its outage is going to be lower, and those user to whom we are going to give less fractions of power is having the more outage probability. It is denoted by user 1 here, red line. Red line shows that it is having the more power, but its outage probability is lesser one. But in case of user 2 to whom we have given the less fractions of power, that is A2 is equal to 0.01, it is having more outage probability. So we can easily here say that where the channel condition is worst, those user which channel condition is worst, we have to give allocate more power to those users, and those whose channel condition is better one, to whom we can give him the less fractions of power.